Hey everyone, I'm Mike, and today we're going to discuss PostgreSQL. Almost every software or web application requires a database in the back end. The increase of transactions occurring per second and the terabytes of data stored calls for a stable and flexible framework for housing and serving up that data. What if we told you that you can access and even build this database free of cost with no strings attached? Yes, you heard that right. The PostgreSQL database guarantees everything I've mentioned, including a few extra perks. In this video, we'll begin to go over various aspects of PostgreSQL that allow it to stand tall in a rapidly evolving segment. But before we get too far, I want to let you know that there'll be links to more resources in the video's description below. And remember, subscribe and ring that bell to get notifications for future helpful content. Now, what is PostgreSQL? PostgreSQL is an open source, highly stable database system that provides support to different functions of SQL, like foreign keys, subqueries, triggers, and different user-defined types and functions. It further augments the SQL language, offering up several features that meticulously scale and reserve data workloads. It's primarily used to store data for many mobile, web, geospatial, and analytics applications. PostgreSQL offers true ACID semantics for transactions and has full support for foreign keys, joins, views, triggers, and stored procedures in many different languages. It includes most data types of SQL like that of integer, varchar, timestamp, and boolean. It also supports the storage of binary large objects, including pictures, videos, or sounds. It is reliable as it has a large built-in community support network. PostgreSQL is a fault-tolerant database thanks to its write-ahead logging. PostgreSQL boasts several robust feature sets, including point-in-time recovery, multi-version concurrency control, table spaces, granular access controls, asynchronous replication, a refined query planner and optimizer, and write-ahead logging. Multi-version concurrency control allows for concurrent reading and writing of tables, blocking for only concurrent updates of the same row. This way, clashes are avoided. PostgreSQL supports Unicode, international character sets, multi-byte character encodings, and it is locale aware for sorting, case sensitivity, and formatting. PostgreSQL is highly scalable in the number of concurrent users it can accommodate as well as the quantity of data it can manage. Furthermore, PostgreSQL is cross-platform and can run on many operating systems including Linux, Microsoft Windows, OS X, FreeBSD, and Solaris. The PostgreSQL server can also include user-written code into itself via dynamic loading. The user can specify an object code file, for example, a shared library that implements a new function or type, and PostgreSQL will load it as required. The ability to modify its operation on the fly makes it uniquely suited for implementing new storage structures and applications rapidly. The PostgreSQL server has a simple structure consisting of a shared memory, background processes, and a data directory structure. Initially, a request is sent by the client to the server. Then, the PostgreSQL server processes data using shared buffers and background processes. The physical life of the PostgreSQL database server is stored in the data directory. Shared buffers. These buffers serve to minimize the server disk I/O. To fulfill this objective, it is fair to set the value of the shared buffer as 25% of the total memory if we have a dedicated server for PostgreSQL. The default value of the shared buffers from version 9.3 onwards is 128 megabytes. It is imperative to try and minimize the contention when several users access it simultaneously. Frequently, used blocks should be in the buffer for as long as possible. This allows it to access the data as quickly as possible. Wall buffers temporarily store changes to the database. The wall file consists of contents written by the wall buffer at a predetermined point in time. Wall files and wall buffers are significant to recover the data during backup and recovery. Work memory. This memory space is used for bitmap operations, sorting, merging joins, and hash joins to write data into temporary disk files. The default setting from version 9.3 onwards is 4 megabytes. Maintenance work memory. This memory slot is used for database operations such as analyze, vacuum, alter table, and create index. The default setting from version 9.4 onwards is 64 megabytes. Each background process is integral and performs the unique function to manage the server. Checkpoint your process. When a checkpoint occurs, the dirty buffer is written on the file. The check pointer essentially writes all dirty pages from memory to disk and cleans the shared buffer area. If the database crashes, data loss can be measured by obtaining the difference between the last checkpoint time and PostgreSQL stop time. Background writer process. It updates logs and backup information. Up until version 9.1, this process was integrated along with the check pointer process, which was done regularly. However, from version 9.2 onwards, the check pointer process has separated from the background writer process. Wall writer. This process writes and flushes the wall data on the wall buffer periodically to the persistent storage. Archiver. If enabled, this process has the responsibility to copy the wall log files to a specified directory. Logger logging collector. This process writes a wall buffer to the wall file. PostgreSQL has several databases together forming a database cluster. When initialized, template 0, template 1, and Postgres databases are created. The new database creation of the user is done through template databases, which consist of the system catalog tables. Although the list of tables in template 0 and template 1 is the same after initialization, only the template 1 database can create the objects the user needs, hence the user database is created by cloning the template 1 database. The data needed for the cluster is stored with the cluster's data directory, which is also referred to as PG data. It consists of several subdirectories, and a few important ones are global. The global subdirectory consists of cluster-wise tables such as the user database. Base. The base subdirectory is the physical location of the default table space. It contains several per database subdirectories within which the system catalogs are stored. PID. The PID file consists of the current postmaster process ID. PG version. This subdirectory consists of the database version information. PG notify. This subdirectory contains the listen notify status data. These files can be useful for troubleshooting. PL PGSQL is a native procedural language provided by PostgreSQL, which has different modern features. It backs the JSON data type, which is lightweight and ensures the flexibility included in a single package. As a result, PostgreSQL supports several programming languages and protocols, including Perl, Ruby, Python, .NET, C or C++, Java, ODBC, and Go. It's free and open source. This is by far the most significant benefit of PostgreSQL. It has been backed by more than 20 years of community development, which in turn has contributed to its high level of integrity. Its source code is available under an open source license that allows you to use, modify, and implement it however you see fit at no extra cost. Objects, classes, and function overloading are directly supported in PostgreSQL. It is possible to extend data types to create custom data types due to their object-oriented characteristics. This guarantees high flexibility for developers operating with complex data models that require database integration. Table inheritance is another feature supported by PostgreSQL due to its object-oriented characteristics. The child table can inherit the columns from its parent table, in addition to the other columns that the child table possesses, making it different from itself. Write operations in PostgreSQL can be performed concurrently without the need for read-write locks. Indexes are used to speed up queries when dealing with large amounts of data, which allows databases to find a specific row without having to cycle through all of the data. With PostgreSQL, you can even create an expression index, which works on the result of an expression or a function rather than just the value of a column. Partial indexing is also supported, wherein only a part of the table is indexed. It also supports parallelization of reading queries, just-in-time compilation of expressions, and nested transactions, ensuring great performance and efficiency. PostgreSQL is highly extensible as its operation is catalog-driven. For example, information is stored in databases, columns, tables, and more. PostgreSQL not only holds an increased amount of information in its catalogs, but also details on the data types, access methods, functions, and so on. You can even go as far as to write your codes from different programming languages without recompiling your database and define your data types. It guarantees high availability and load balancing through standby server operation, continuous planning, preparing the primary for standby servers, setting up a standby server, streaming replication, replication slots, cascading replication, and continuous archiving in standby. Additionally, PostgreSQL supports synchronous replication, where two database instances can run at the same time, time, and the master database is synchronized with a slave database simultaneously, further ensuring high availability. In addition to storing data securely and allowing the user to retrieve the data when the request is processed, it is backed by a community of contributors that regularly find bugs and try to improve the software, making PostgreSQL reliable. The process of designing software so that it may be utilized in a range of regions is known as internationalization. It supports international character sets through multi-byte character encodings, ICU collations, Unicode, and it is locale aware for sorting, formatting, and case sensitivity. Viewing PostgreSQL generated messages in the language of your choice is an example of internationalization. Do you need to build complex queries and relationships that need to be frequently updated and consistently maintained in the most cost-effective way possible? PostgreSQL might be a suitable option. Not only is PostgreSQL free, but it is also cross-platform and not just limited to the Windows operating system. If you want to analyze data, PostgreSQL provides a vast amount of regular expressions as a basis for analytical work. It is also one of the finest databases when it comes to CSV support. Simple commands like copy from and copy to help in the fast processing of data. If there is an import issue, it will throw an error and stop the import immediately. Let's look at some of the most common applications of PostgreSQL in the modern world. The PostGIS Geospatial Database Extension add-on for PostgreSQL is undoubtedly beneficial. When used along with PostGIS extension, PostgreSQL supports geographic objects and can be utilized as a geospatial data store for geographic information systems and location-based services. PostgreSQL is an ideal DBMS system for the financial industry. Since it is fully ACID compliant, it is an ideal choice for online transaction processing, as these databases need to be written, read, and updated frequently, along with an emphasis on fast processing. It is also apt in executing database analytics. It can be integrated with any software that carries out mathematical operations such as MATLAB and R. Scientific data require terabytes of data. It is imperative to handle the data in the most efficient way possible. PostgreSQL provides wonderful analytics and a powerful SQL engine. This helps to manage a large amount of data with ease. Websites often deal with hundreds or thousands of requests per second. If the developer is looking for a cost-effective and scalable solution, PostgreSQL would be the best fit. PostgreSQL can run dynamic websites and apps as part of a robust alternative to the LAMP stack. Many startups and large enterprises use PostgreSQL as the main data storage solution for products, solutions, and internet scale applications. Supply chain performance can be optimized by using this open source DBMS as a storage backend. As a result, this allows companies to reduce the operation cost of their businesses. So far in this video, we've only sung PostgreSQL's praises. So here are a few operational challenges that you might come across during the process of PostgreSQL adoption. Lack of a mature database ecosystem. PostgreSQL boasts one of the fastest growing communities, but as opposed to traditional database vendors, the PostgreSQL community does not have the comfort of a developed database ecosystem. The dearth of expertise. PostgreSQL is often coupled with various databases such as MongoDB. Now, each database needs specialized prowess, and hiring technical staff with the desired PostgreSQL proficiency can be a tall order to fill. Along with management tools for PostgreSQL, database experts and DevOps teams need to tackle various databases from multiple vendors. This can be difficult to manage when you can't switch between existing processes. Inconsistency. Since PostgreSQL is an open source tool, different IT development teams within an organization can start leveraging it organically. This might lead to another roadblock: lack of a single point of knowledge for all instances of PostgreSQL within the IT environment. Another problem that might stem from different teams trying to solve the same problem is duplication and redundancy of work. Kinsta's WordPress hosting can speed up your website by up to 200%, and you'll get 24/7 support from our expert WordPress engineers. Let us show you the Kinsta difference. Try a free demo of our My Kinsta dashboard at demo.kinsta.com. Thank you so much for watching, and don't forget to subscribe to find more tutorials, explainers, and helpful content like this.